Okay, this is a video for those of you who missed my amazing discussion about getting velocity versus time for something that's falling in air with resistance. We are modeling a coffee filter falling quite simply with a force of air resistance. So force of air just equaling a BV. Drag coefficient multiplied by the velocity at any given time. Now our job is to find the velocity time equation for this. Let's get started. So we know that going upwards is force of air. Downwards, of course, is force gravity. Now for this video, I'm going to make this direction positive and then upwards negative. So then my net force is equal to force gravity minus force of air. Now I'm going to substitute in BV for my force net equation for force air. And I remind myself that at terminal velocity, force of gravity does equal force of air. Okay, so what can that equal then? Well, force of gravity then is going to equal B times velocity terminal. Because at terminal velocity, those two are equal to each other, and I just plug in velocity terminal. So my force net equation now becomes simpler. It now equals B times velocity terminal minus B times whatever velocity I'm at. Now what am I going to plug in for force net? Always MA. So MA is equal to, and I'm going to factor out a negative B in this terms here. Okay, so that would give me V minus V terminal multiplied by B. Now I'm factoring out negative B because I know later that will make my life easier. I'll divide both sides by M to get acceleration by itself. Acceleration is minus B over M times velocity at any time minus velocity terminal. Now I'm going to need to integrate, but I don't have a differential expression yet. A, I know, is a differential of dV over dt. And that, of course, equals minus B over M times V minus Vt. That, of course, is still not integratable yet. I need to get all my variables on the same side. So I'm going to take dt to the other side, and I'm going to take V minus Vt to this side so that they are on the same sides. Right? I paused the video just briefly there to get space. So now I have dV divided by V minus the terminal velocity. Now remember, V at any time is going to equal minus B over M, okay, times dt. Now we're going to do an indefinite integral on both sides. So I'm doing the integral symbol on this side, the integral symbol on this side. Okay, now the integral of dV over V, if you remember the natural log, the derivative of natural log gives us 1 over x. The derivative of natural log of V would be 1 over V. So when I integrate this side, I'm going to get the natural log of V minus Vt. And this one's going to be minus B over M T plus some constant C that may have fallen off. We'll be able to figure out what that is soon. Okay, so now I have it in terms of a natural logarithm. So if I e to the x this side and e to the x this side, I will get rid of natural logarithm here. So that's V minus Vt equals e to the minus B over mt plus c. Because I'm taking e to this whole side. Now, based on exponents, if I have addition of exponents, that's the same thing as multiplication. So then I've got V minus Vt is equal to e to the minus B over mt times e to the c power. Now I need to figure out what e to the c power is. Well, if I plug in time equals 0, that's our beginning moment just when we drop this. So e to the 0 becomes 1. Therefore, this side here is just e to the c. But my velocity beginning is 0. So with this becoming 1 and this becoming 0, e to the c is equal to minus velocity terminal. So I'm going to put minus velocity terminal in for e to the c power. So now I have v minus vt is equal to minus vt e to the minus b over mt. I want to get v by itself, so I'm going to add vt to the other side. So velocity is going to equal then velocity terminal minus velocity terminal e to the minus b over mt. We're almost done. I'm going to factor a vt out of this. V then is going to equal velocity terminal times 1 minus e to the minus b over mt. And there's our final equation. Now let's test it for validity. When I first drop this, my velocity initial is 0. So let's put in a t equals 0 here. So t equals 0, this becomes 1. 1 minus 1 is 0. 0 times vt gives me 0. My initial velocity is 0. After a long time, let's say time approaches infinity, this becomes e to the minus infinity. Therefore, this becomes 0. 1 minus 0 is 1. And therefore, velocity terminal is our velocity value after a long time or close to infinity. So the validity of this equation is verified. At time equals 0, velocity equals 0. Time equals very long, we are now at velocity terminal. And that's our equation for the day.